Okay, we've got triangle ABC, midpoints M and N of sides AB and BC respectively. And we're asked to prove that triangle MNC, that's this little blue triangle, is its area is a quarter of the area of the big gray triangle. Okay, now I'm not going to write a 2-column proof for this whole thing. You'll have to clean it up if you need to do that, but I'll take you through the general idea. Okay, so the midpoint theorem for a triangle says that if you connect the midpoints of two sides, that the segment joining the two midpoints is parallel to the third side and also 1/2 of the third side. And we need both of those pieces of information. So one thing that we're going to notice is that the big gray triangle is similar to the top little gray triangle at the top, MBN, by angle, because of corresponding angles. We got two parallel lines cut by this transversal. So angle A equals angle BMN, and they share angle B. So those two triangles are similar. And if triangles are similar, their altitudes and sides are in the same proportion. And in this case, it's 2-to-1 because of these midpoints. So side AB is twice side MB. And if I were to draw an altitude here, then this altitude would be twice the altitude of that segment right there. Or these two segments are congruent. Another way to think about it. Okay, so what you have to do to picture this is to extend side MN, if necessary, to create an altitude for that triangle, and draw the altitude from vertex B to side AC. I've labeled the points of intersection for discussion purposes. But the area of triangle ABC is using 1/2 base times height. AC is this side. The height is, we're saying this is an altitude, so that's a right angle. And so is this, because these lines are parallel by the midpoint theorem. So BP1. So there's a formula for the area of triangle ABC right there. And a formula for the triangle area of triangle MNC is 1/2 its base, which is MN, and I've created this vertex right here, or this altitude right here, by dropping a perpendicular from vertex C to MN extended, depending on where, well, I guess we'll always have to extend that. So here's some pieces of given information that allow, or of deduced information that allow us to draw the conclusion. MN is 1/2 AC. We've already seen that by the midpoint theorem. BP2 is congruent to B1, P1, P2. That means this side, this segment is congruent to this segment. And that's because the big triangle and this little triangle at the top are in the ratio 2-to-1. And CP3, this altitude right here, is equal to P1, P2 because parallel lines are everywhere equidistant. And that allows us to conclude that P1, P2 is 1/2 of BP1. Hopefully you can see that. So we're going to take the formula for the area of triangle MNC and do some substitutions. So here's the 1/2 from the formula for the area. MN is 1/2 AC. That's a substitution. CP3, this is like the transitive property. We went to here, equals 1/2 BP1. And now if I take two of these halves out front and leave 1/2 AC BP1, that's the formula for the area of triangle ABC. Okay. And that's the proof. Okay, there's a lot there if you need to do a 2-column proof, but hopefully that gives you the idea of how to proceed. Hope that helps.